Hello, everybody at home. So today we're going to be talking about basically what amounts to over-engineering a checkbox. So obviously the pandemic has presented a really unique situation for the government and has really pushed us to transform. Um, so we had a requirement at ESDC to develop a solution that could identify critical employees and those that without laptops that needed laptops. Uh, so this solution should have basically been a checkbox, but due to the limitations of a bunch of factors that we're going to be discussing, um, we had to develop a whole other solution. So this is our journey, and today I'm presenting with Jason McIntosh from TBS and myself, Omar Nasser. I work at ESDC, and these are the Twitter handles if you want to follow us or ask us any questions following.
To get things started, we'll discuss who is involved in this initiative. So the teams are composed of two main teams across two DGs in the same branch. So I was at the time on an IT strategy team who generally didn't do much development, but we had development capabilities in the team. So we were asked to shift over to do some development work for the department. And then we worked with another team in the department who was also trying to push DevOps. So this is a good example of how teams can work together with different capabilities to realize the delivery of modern services in government. And why are we taking the time to present this to you? Why was it a noteworthy achievement? What we were able to do is demo an early version of the application to our CIO within 10 days by leveraging open source software. We were able to demo it to two DGs even before this. We were asked to start working on this on a Thursday afternoon. And by the following Monday, we were able to start demoing early versions or prototypes of our application to who we thought were users at the time and two DGs. And as well, we were the first app on PB Cloud. And we were also able to be on PB Cloud within minutes of it becoming available to the department. We also had users on production testing the application within 2 hours of our application being on the production environment. And the 2 hours is only because of scheduling problems. As far as the tech is concerned, we could have had them on within minutes as well. As for how we organize the teams to do this, I borrow a lot of these ideas from a book called Team Topologies. On the internet, it seems to be referred to as DevOps teams these days, but it's borrowed from a book called Team Topologies. And I'd say the two core components, at least for this presentation that we're going to focus on, is increasing flow and upskilling teams. So how do you do that? In the book, they define 4 types of teams. There's value stream aligned teams, platform teams, enabling teams, and complex subsystem teams. Here you see in purple, that is the enabling team. You have the platform teams, which are the blue ones, and then the value stream aligned team in yellow. In our case, and we didn't strictly follow this throughout the presentation, I think that the structure of your teams should change as the project evolves, as your requirements and needs and the situations and circumstances change. So this is kind of a snapshot of how I initially envisioned it, although near the end of the project, we didn't stick rigorously to this organization. But it's an example of how we can implement these different team structures from this book in the Government of Canada. In our case, the yellow value stream aligned team was IT strategy, mostly focused on the application. And the platform team, which was a team called DTS, was mostly focused on the platform stuff. By and large, the demarcation point, you could say, was the master branch or the dev branch, I don't remember now, on the repository. So as soon as we pushed code to that branch, it would kick off the automated process, and the automated process was the responsibility of DTS. So the teams were able to communicate efficiently. Well, we use Slack, so we can communicate there. But a lot of the communication with respect to when things were supposed to happen happened through automated processes, which allowed us to do on-demand deployments. It's not often we did many deployments a day, but we had the capability using this way of working. And for more details on how to organize the structure of teams, I would recommend reading Team Topologies. It goes into more detail about how best to use these teams. For example, the value stream aligned team should be your most common team. The platform team's job is to remove cognitive load from the value stream aligned team so they can keep delivering value to users, which creates the flow. The platform team shouldn't be creating more work in process for the value stream aligned team. It also defines different modes of communication. The preferred one is X as a service. I'm going to extrapolate here and just say some automated way for teams to communicate that isn't submitting a form or a request by email. So the book talks a lot about X as a service. In our case, we just used a certain branch on a repository as a hook to start an automated process. But for more details, I recommend you read the book. Okay, so now applying these ideas to government. The book itself is not focused on government, but the way that we applied it was within a government context. So the way that we did that, if you go back to the previous slide, Omar, for just a moment, the way that we did this is the project manager, I guess we could say, is a director who's responsible for the project. And then under the project, you have multiple managers. In our case, the multiple managers were actually not under that same director. It was from throughout the department. So we kind of made a matrix organization to make this work. And then you have the product owner. So in our case, the manager and product owner were the same people, but that ideally shouldn't be the case. Ideally, we'll have managers and product owners, and the product owner is the one who's responsible for ideally being from business, collaborating with users, prioritizing items in the backlog, joining the team for their planning, and all this kind of stuff. The manager would be, or in this model, which is roughly borrowed from the Spotify model, which I believe we'll cover in one of the following slides. The manager is responsible for a team of, say, testers, and then the product owner would borrow resources from the managers and then use those resources to deliver their product. So ideally in this model, they wouldn't be the same person, but in our situation, they were. So if we move on to the next slide now, right, so why all of these different ways of organizing teams, not just the functional teams that we have now, where you have your testing team and your developing team, and they communicate through email and all this stuff. What's with all these colors and new words for how teams work? Well, as we discussed in the beginning, we're really focusing on upscaling teams and minimizing size. And that's actually saying the same thing twice. What we want to do is we want to have the smallest number of people delivering the maximum number of value. So that means if you have two choices, one choice is to hire someone to import a new competency into the team, say like accessibility, but that grows the team. So it's one option, but is that the one you want to take? Well, that depends. The other option we have is just to upskill the team. And this is when enabling teams come in. So let's say, and this was the case with our team, we didn't have an accessibility expert. They were otherwise busy from the other teams. So we assigned a champion. And ideally, we could have an enabling team, maybe someone who is from accessibility, that's their full-time gig, to come in and enable the team, to upskill the team. And then the enabling function would leave after a few weeks. And the team has now gained a new competency. And in that way, we've able to upskill the team and keep the team as small as possible. So we have the fewest number of people delivering the most value. And this model supports work like this. So with that, I'd now like to hand this off to Omar to discuss some more of the technical details of how we deliver this project.
Thanks. Yeah. So obviously this is a technical conference, so don't worry, we're not going to skip up on the technical stuff. That's why you're here. I really like this meme. In government, we think that just by using cloud, automation comes with it, and that's not the case. You still have to build in automation. You still have to build in your pipelines. Cloud and cloud without any automation is pretty much useless. So if you're just spinning up, VMs on Azure or AWS or whatever cloud solution that you go with, and you're deploying things manually through command line, you might as well just host on-prem, since we already have the infrastructure. The main thing with cloud is it's supposed to reduce the barrier of entry for automation. It's supposed to make it easier, but you still have to put in the work. So this is sort of the high-level architecture diagram of our solution. I could talk about sort of our tech choices, and I will a little bit, but we mainly went with Kubernetes to host and sort of manage manage a lot of the automation, and that's because we had a team with that competency. I really want to stress that it doesn't really matter sort of what technology you can go with. People will argue, you should always use Kubernetes, or no, Kubernetes is overcomplicated. It doesn't matter. You need to look at what skills your team has, and what you're able to do, and basically just pick something and stick with it. That's that's really what matters. So we had a team with that Kubernetes competency, and since we were using containers in any case, we decided to just use Kubernetes, and that was the easiest solution for us. Um, so there's a lot going on here, but basically, to manage pipelines, we were using Jenkins. So we had two separate Kubernetes clusters. And each in different subscriptions. So we had one which is sort of like our dev and staging cluster, and this was in a sort of a dev subscription, and we had a completely isolated subscription with our production B sort of production cluster, and even the Jenkins instance was separated. So there was some things that we had to do, like for example, the production Jenkins wasn't accessible. You had to essentially proxy through one of the pods on the production cluster to be able to access the production Jenkins, and we couldn't do any hooks from GitHub to the production Jenkins for security compliance. Obviously, this is not something that's ideal, and we'll discuss that a little bit later on. But that's essentially what we had to do, and we had a lot of automation built in terms of checking for like security, so pen testing, accessibility as well, and as well as data import, where obviously because we had data behind a firewall, we couldn't. Unfortunately, there isn't any cloud to ground connection. So we had to figure out creative ways to sort of extract data from PeopleSoft and Active Directory and essentially run jobs to update the data in the whitelisting app so that the data is not stale. On the GitHub side as well, because we're using GitHub, we had a lot of stuff already there that comes for free. GitHub has static code analysis for security vulnerabilities. So it'll look at your dependencies and inform you of any vulnerabilities. This has been very useful for us. In terms of making sure our application is secure. We really focused on, try to focus on application security and network security in itself rather than, compliance, but we'll talk a little bit more about that later.
So something that I want to highlight that we discussed during the previous set of slides is about the flow. And I think this picture represents a good example of the flow. So if you click on the image, it'll become quite larger. In case we can't see, there's a line on the right-hand side that connects the two most right-hand side boxes. And that's important because we want to stress that this is very intentionally creating like a circle, like a flow of work. So, you have your repository, which it has automated checks running against it, which create issues against the repository that we put in place, that we then build into the deployment process, which itself, again, then also gets run against more security checks. In this model, they're over to the right, and we ran these locally. Ideally, they would have been down to the left as part of the deployment process. But remember that we built this entire architecture in about a month. So this isn't what I would call, and I would not use this word anyway, an end state architecture, as though that exists. This is like a very transitional architecture. There's a lot of improvement to make to this process. But what is important about it is that as the cycle goes through, or as the cycle completes, at each stage, we're feeding more issues back into the GitHub repository so we can continue improving the application. For example, once the website's deployed at the bottom here, you see that we're running accessibility tools against our deployed version, which we then feed back into issues, which goes back to the start of the cycle. So it's a very circular motion, which is going back to the idea of creating flow. And we want to make sure that we're able to continually improve this application, plugging in tools that satisfy different capabilities we're missing. For example, we have automated accessibility checks. We have automated security checks. Two sets. We have the dependencies that we were talking about. We also did some fuzz testing, which we used to generate more issues for the repository. So we have some QA. So we had some basic Selenium tests, making sure that the application came up as it was supposed to during the deployment process. And all of these automated tools help increase the quality and security of the application, as well as feed back into GitHub to create more issues for us to continue improving the application. So I just want to note the circular shape that's very intentionally built in so that we can create a nice flow when we're trying to deliver value to users.
The concept of actually end architecture doesn't exist. It's always evolving, it's always changing, it's always adapting to the world, right? I'll go into a little bit of the actual cloud architecture. We did touch on it in the previous high level architecture slide, but just to put it in terms of Azure contexts, I think most of the government really is on Azure now, but if it's on AWS, it's a little bit of a similar concept. So yeah, we mostly use Azure Kubernetes Service. So that's how we provisioned our clusters, and had rules in our network security group, so that we prevent any unwanted ports from being exposed to the world. So our cluster was in a VNet. And we basically, and obviously Kubernetes has providers which dynamically provision disk and CPU. And then we were using mostly Postgres in a separate network policy, so to make sure that it's not exposed to the internet. So we used a lot of tools, again, like we talked about. So Jenkins was our sort of CI/CD pipeline of choice. And once again, we chose Jenkins simply because we had people on the team that knew how to use Jenkins. All these tools are very, very similar. So really, it's just a case of pick one and stick with it. So Terraform, it was used as infrastructure as code. So that's how we provisioned our Kubernetes clusters. We used Helm as well for the Kubernetes the images that would run on Kubernetes and some automation there. And for monitoring, we used a mixture of different tools. Elasticsearch for logs and Kibana to be able to search through the logs, as well as a whole bunch of other tools, Graylog, Grafana, Prometheus. And we also had I think an internal ticketing system for the cluster to be able to sort of alert the SREs when things went wrong. So for the open source application, we built it off Odoo, and Odoo is a very large open source ERP system. And Traefik was used for basic, like a DNS, dynamic DNS allocation. So when the pods spin up, Traefik will point the DNS to the relevant IPs. So yeah, that's basically our sort of cloud infrastructure as a quick overview. Once again, I really want to stress that we just use these tools because we had competencies on the two teams to use it. One other thing is that we could probably do this in Azure on App Service as well. That's also a possibility. So really look at your team, look at the competencies, look at what they're willing to learn, and sort of pick something and stick with it.
So all of this is in the open. If you are looking at this and you are mildly interested, as the geeks we are, you can reach out to us and we can send you the links for the full presentation itself and also all of the diagrams that we're referencing here.
One of the really big hurdles that we ran into was security. The model of security in the government is from a regulatory and risk management perspective. We're not really as focused on network security and application security as we are just making sure that we tick all the checkboxes. So we actually received a checklist of approximately like 300 items, and Jason can tell you a little bit more about this because he actually had to go through each one of those items and make sure that we were compliant. But a lot of these items were irrelevant. Like we got stuff like, do you have a fire hose beside your server or something like that? So we have to really the castle and moat approach, where basically everything behind the firewall is assumed to be secure and everything external is assumed to be a threat, has to change. Obviously, with cloud now being the sort of the predominant or approach the government wants to take, you're going to have different applications basically everywhere. and different pieces of data basically everywhere. So this approach is no longer relevant to basically what we need from a security perspective.
Yeah. To elaborate on the checklist of approximately 300 items that Omar was discussing, we did have to go through these. There was a whole batch of them that didn't even directly apply to our situation because they were asking about the zoning that we applied to our solution, which didn't really map onto cloud. But I'm sure we'll improve that in the future. Cloud is decently new to government. It's not a new technology. People say that a lot. It's not. AWS is from 2006, roughly. So this is a 15-year-old technology in the technology world. That's not new, but it's new to us. So we have some adjustments to make with respect to these long checklists that we have to fill out. But I would also add that we have these long checklists, and they tell you to check all sorts of stuff, which is good to be thorough. But the irony is that there was one moment when we launched the application locally, there was some functionality we had for refreshing the database that accidentally got deployed to production. Now, the functionality didn't exist, but we did have a button that didn't work but was present that essentially looked like if you clicked it, you could wipe out our database. And this was just hosted on the production version of our application. Now, I'd say that would be a security risk. You could dump the database and get access to it. You can clean our database and say this is a security risk. But through all of these granular 300 item checklists, none of them caught having a button on your front page that says delete my database. So I think we need to be careful about what these 300 items are checking and to not let these 300 items give you a false confidence. I think there's some discussions to be had whether or not we change the 300, we take the 300 and add to it. Security is not my area of focus. But I will say there's a lot of improvements that we can make. Just because you go through these 300 items doesn't mean your application is secure. So I think there's some room that we can do to make sure that people who want to be secure are making their applications as secure as possible by following these checklists rather than having this as a paper exercise.
Yeah, so that's where we get into like what security should be. Like in the era of where cloud is now used widely across government, how should security evolve? So this is where we start talking about the zero trust model. So this is where just because something's behind a firewall, so firewall not equal security. There are internal and external threats, and we have to make sure that we secure things on a component by component basis or system by system basis, and not really depend on just the network. So the way that we do this is, IT security should provide, automated security checks and tooling so that developers and SRE folks can easily include that within their pipelines. And so by passing these automated checks, we are confident that we are secure. So the other thing is we should really focus on application and network security. So what it actually takes to make an application secure, again, on a system by system and component by component basis. We don't really, we focus more, again, on compliance and making sure that we won't get sued rather than actual application and network security.
And like in the last slide, Omar, your JavaScript is showing with your double equal sign. For your,
yeah, my JavaScript is showing. Yeah, I've added myself.
How do we get there then? So we've talked a lot about delivering an application, showing it to your CIO in 10 days, using cloud and this architecture that we built in a month. We talked a little bit about your architecture and whether or not having a rigorous stack that everyone must follow is the best way of going. And I think if we could underline this in one sentence, we would say, with respect to choosing your stack or with respect to how we should be developing applications, hire good people. Don't hire good people to tell them what to do. Hire good people to let them tell you what to do. And this gets into distributed decision-making. The people closest to the problem are the ones best suited to solve that problem. And I think we need to really embody this in the way that we make decisions going forward, because it becomes particularly important when we get to automation. If we're going to automate, you're going to have to trust in the automation, trust in the people who implemented the automation. And that's where standards become important. Well, what is a sufficient amount of automation to be comfortable that when I deploy this, it's going to meet OL compliance and accessibility compliance and security compliance and all this stuff. So the standards become, how do people need to act to ensure that we're delivering quality software? A useful question is not, are they using Kubernetes or are they using Jenkins? That's up to the team. I mean, you may want to have standards like something, we only have one framework loading on any one given page. That may be a useful standard to implement. But specifying which tools and taking control away from the people who are best suited to make that decision is not a way to go if we want to get to modern software delivery and be able to do on-demand deployments so that we can make sure that we're delivering value constantly to our users.
Yeah, so there's a whole bunch of other stuff as well. Obviously, hiring good people is one of the most important things, and giving them the freedom to sort of make decisions. But obviously, we need access to modern tooling. We need to be able to automate things, and again, we need the necessary skills and interoperability. One of the most difficult things that we faced, obviously, we did a lot of this stuff on our personal machines. It was good that we were able to use our personal machines to do this, but other people may not have access to that. And being on an on-network device, it's really difficult to get the tooling that you need to get the job done. So one of the things we have to change is giving developers the freedom to use tooling. That's where we mentioned the zero trust model. But what about our security? We can't just let developers use whatever tools they want. They may compromise the network. Again, we have to assume that there are an equal amount of external threats to the network as there are internal threats to the network. And again, the way that you get around that is to make sure that you have automated checks on your network and your applications to make sure that they themselves are secure from any internal or external threats, not just external threats. So that's what we need to do there. And then again, necessary skills and interoperability. Part of Stratosphere is to sort of inspire people to build people and teams to build these skills. So we really desperately need people with technical skills to be able to do this. So otherwise, it's not possible.
Now we're going to get into the last section of our presentation, where we want to underline the good, bad, and the ugly. As we said, there were a lot of good things about this initiative. We got it out of the door very quickly. We used multidisciplinary teams. We had access to rogue tooling. Discuss that in shortly. And we discovered that it's possible in at least one universe. The route that we took is different than what others will take. It's not a scalable approach. Because we needed this out ASAP, we got an authority to operate directly from the CIO. We didn't have an SANA conducted prior to the launch of the application. For that reason, while we were in a PB environment, our application was not certified PB, so we had to remove any protected information to the application before we deployed it. But authority to operate from the CIO is not scalable. Everyone in your department, or at least not in a large department like ESDC, can't take this approach. So we've demonstrated that it's possible, but we need to make sure that now that we know it's possible, we put the proper processes in place so that this is possible in a more scalable way, a more sustained and scalable way. And we put here access to rogue tooling because, as Omar was talking about previously, it's good that we had a bunch of very motivated people in our teams who are willing to use their personal devices, who knew how to use cloud technologies and GitHub and Slack and put automation into Slack so we know what's happening with our builds across the teams and all this kind of stuff. That was good, but we'll get into the bad side, which is, well, why did we have to do that in the first place? Why couldn't we have developed or delivered something in 10 days using tooling on our local computers? I mean, for the example of IT strategy, who's not a development team, to get access to the tools we needed to write this would have taken probably more time than it took us to architect this entire solution and deploy it and onboard the entire department. That was also in the month and a half long timeline. We had regular meetings with branches throughout the department to onboard them onto the tool. We wouldn't have been able to move at this pace using the tooling that was available to us within the department.
Yeah, so Jason's much more positive than me. So I'll be talking about the horrible stuff or the bad stuff. So again, this was a Band-Aid solution. During the panic, we just basically put two teams together and try to come up with what was possible in the quickest and shortest time possible. So the source of the data for our system was Active Directory and PeopleSoft. And obviously, because we had no mechanism to be able to directly connect our two systems, because there's no cloud to ground connection, what we had to do is create a MS SQL database on our network, take the Active Directory and PeopleSoft data, munge that into the MS SQL database. Then we had to write a PowerShell script, which would run on somebody's machine and periodically upload this to a Azure Storage account, and then that would have to trigger a job on Jenkins to be able to take this data, munge it, and then use the Odoo XML RPC API to push this data into our system. So you can see the basically amount of steps and where things can go wrong simply because we could not access these systems from a system that was approved. Not only not only did we show that was approved by our CIO. So this was like one of the major issues that we ran into, and we'll talk more about this in the sort of the ugly side of things, but that was really one of the biggest issues that we had. And the other thing was, again, too much work and too little time, so everything was really rushed, obviously because we wanted the solution now. But if we actually could have taken the time, we could have looked at our internal systems and seen how we could have developed interfaces to be able to basically build a simple solution. Because this, again, essentially all we needed to do was check which employees were critical and basically if they had laptops or not. And we had to essentially use what amounted to a full-blown ERP system, because we weren't able to sort of plug into Active Directory and PeopleSoft directly. So that brings us to the ugly. So because the teams were sort of put together, when we reached the MVP state, there's other projects for us that we have to do. So we couldn't, ideally you should have a product team that is dedicated to the products that you create, but in government, obviously, this is difficult. Often, the skills in the organization are not well distributed, and there is and as such, and they're not really present as much, and as such, a lot of these teams with the skills basically get a whole amount of projects that they have to do, and this makes it difficult when we're talking about maintenance and ownership issues. Basically, we're not able to get new data into the application because we don't really have anybody with the time to be able to actually find a better solution to do so. So that was really, part of the ugly. So maintenance issues and ownership issues, and I think this is, it's a larger problem in government, but is one of the things that we ran into.
Yeah, so I'm glad Omar discussed the interoperability issues. I think it's important, but I really want to sell this issue home because I think it's maybe the core issue that I think was the impetus for this entire initiative. If it were the case that our existing solutions were more agile, to buzzword, and we could have just asked some product team to add a checkbox to an existing system like PeopleSoft, then that would have been it. Our whole job would have been done, but we can't. We talked to people about adding this checkbox to existing solutions, and the wait times were horrendously long. People didn't even know if we'd be able to put the checkbox in the application. So just our lack of agility is what made the need for us to create this new agile solution. All of this engineering was a production of our lack of agility within the organization. It's when they often talk about in DevOps literature, they say firefighting is a bad sign. The fact that people are always firefighting, I mean, thank you to the firefighters. You're doing good work, and we thank you for doing this. But you shouldn't have to. That's the sign of broken process and non-agile software. For example, we had to do this ASAP and put in tons of overtime. Um, Lots of overtime. You can let Omar himself tell you how much he did if he wants to unveil this information.
I think I did like 100 hours of
Yes,
overtime,
so 70
quite
or 80
literally.
hours
Yeah, or
in 1 month
something like that.
anyway.
Yeah.
With the other month probably close to 100. But this was only because we couldn't put a checkbox in an existing solution because our processes and software is slow. The other thing I would say is, so that's our lack of agility is causing the need for firefighting. We shouldn't have had to do that. Although when we did, it was a success, which is why we're here talking to you now. The other thing that I think is important to underline is, as we discuss, is interoperability. This is departments all over the place are making good efforts to address interoperability. They know it's a thing they should do. They say we need to use APIs, although there's no other option in software. That's how software talks. So we should probably put a finer tip on this conversation. But what I mean to underline is we made an API available to people for people to pull and even update and interact with the information in the application because it's 2020 and these things usually come for free. It didn't use REST; it used some dated protocol. I forget which one it was, but it was there. And we had people from throughout the organization asking us how they get access to our Oracle database. And the answer is we don't have one. And B, it's on the cloud, and we're not exposing our database to the internet. So you can pull something directly from our database that you shouldn't be doing anyway. But throughout the organization, the capability did not exist to interact with our application through the endpoints that we made available for that exact purpose. So if we really want interoperability to exist in the government, it's not about creating a team and telling them to be interoperable, whatever that means. We all need to onboard these capabilities into our team. If you work with data, you should be able to write a short little Python script or Java, I don't care, whatever language. You should be able to write a quick one-pager to pull data from an endpoint. Not everyone needs to be an application developer and care that version 3 of Vue just came out and updating GitHub repositories with all these pipelines and whatnot. That's not what everyone needs to be able to do. But what needs to be a commonplace competency is being able to interact with endpoints so that we can leverage each other's sources of information. If we were able to do that, it's another thing that could have reduced the complexity of this system. We could have built something internally maybe, if we had access to tools, just pull the information from an existing data source directly from PeopleSoft or Active Directory maybe. But again, this is not an option because none of the solutions are interoperable. So this only became such a large over-engineering problem because we haven't solved yet our need for our more agile processes and more agile software, and for our solutions to be interoperable, and for teams to onboard these capabilities into their teams. And then, of course, we had the maintenance issues and ownership issues that Omar discussed. And with that, we would like to transition into questions.
Yeah, so we're recording this in September, but I think we're going to be on YouTube Live. But also feel free to DM any of us on Twitter. So I'll put that, I'll shamelessly plug our Twitters here. So if you're not able to get your question on YouTube Live, then you can always feel free to tweet at us or message us DM us, and we'll be happy to answer any of your questions.
Yeah, so we hope you learned a lot, and thank you for attending our talk on over-engineering a checkbox.